Hello, my dear students. In the last lecture, we started one important point from the chapter, that is the strength of bases and the inductive effect. So, we already completed one example from this strength of bases. Now, after that, in the current lecture, we have to take some more examples in order to study how the strength of bases is affected by the inductive effect. So, for this purpose, we take here a new example of the organic compounds, that is, consider all types of amines. We have to consider all types of amines. All types of amines we have to consider here. We know very well that these amines are nothing but the derivative of the ammonia. So the parent compound for this amines is nothing but our ammonia. So this ammonia is there. So from this ammonia we may form here first amine, that is called as a primary amine. Secondly, we may form here a second type of amine, that is a secondary amine. It is a secondary amine, and in the case of this third case, it is a tertiary amine. So these are the four different examples of these bases. This first is called as a simple ammonia. It is our simple ammonia is there. This is called as a primary amine. Primary amine is there. It is a secondary amine. Secondary amine, and this is called as the tertiary amine. Now we are interested to study the relative strength of basicity of these four compounds. So for this purpose, what we have to consider here, we have to consider what type of inductive effect can be shown by these compounds, or what type of inductive effect is present in all these compounds. So we know very well that the alkyl group, as the number of alkyl groups increases, it increase the plus I effect. Plus I effect can be increased as the more and more number of alkyl groups are present. In this case, one alkyl group is present. In this case, two alkyl groups are present. In this case, three alkyl groups are present. So naturally we can say that the order of inductive effect, the plus I inductive effect, plus I effect, plus I effect, if we look towards the magnitude of this plus I effect, what happens? Due to the three alkyl groups which are present in this tertiary amine, we can say that this plus I effect is more in case of this tertiary amine. Tertiary amine has a more magnitude of plus I effect than that of the secondary amine. Secondary amine has a more plus I effect as that of the primary amine, and it has the more plus I effect than that of the ammonia. And we know very well that as this inductive effect going on increasing, it affects the strength of the basicity, means it is a directly proportional to the strength of bases. So we can say that the expected order of basicity, therefore expected order of basicity of these compounds. So what is the expected order? We can say that this tertiary amine, or we can say that this ammonia is less basic. Ammonia is less basic than that of the primary amine. This primary amine is less basic than that of the secondary amine, and this secondary amine is less basic as that of the tertiary amine. So this is expected order of this basicity on the basis of the plus I inductive effect. But what happens if we consider the pK values of some bases? If we consider the pK values of some bases, so for this purpose we consider here some experimental data. We consider here some examples. This R is a nature of the what type of alkyl group is there in these different amines. So first we consider here primary amine, primary amine. Next we consider here secondary amine, and next we consider here tertiary amine. Tertiary amine is there. So we have to consider some experimental data. As we take here, suppose R as a methyl group. If we take here R as a methyl group, and second case we take here R as a ethyl group. Now we have to consider the different values of pKa when we take substituent of this R as either methyl or ethyl. If we take the R as a methyl, then the pKa value for this primary amine is a 10.6. The pKa for this secondary amine is a 10.8, and the pKa for this tertiary amine is a 9.8. When we take R as a ethyl group, the pKa value for this first primary amine is a 10.8. pKa for the secondary amine is a 11, and pKa for this tertiary amine is a 10.7. So this is one table in which we consider here a different values of this pKa in these three different compounds. So we take here this type of the tabular data. So what is this? It is a pK values of bases. These are the pK values. pK values of bases. Now, if we look toward these pK values of the different bases, we know very well that this pK value is directly proportional to the strength of base. So, if we consider the first case, if the nature of this R is a methyl, then what happens? If we look toward the value of this pKa, the pKa for this secondary amine is more than that of this primary amine, and it is more than that of the tertiary amine. While in the case of this next case, if we take R as a ethyl group, the value of pK is more in the case of this particular secondary amine, and this pK value is more than that of the primary amine, and this primary amine has the more pK values as compared to tertiary amines. So what is the case for this particular? We can say that these all amines, all primary amines, these all primary amines we can see here are weaker base. All these primary amines are called as the weaker base as that of the secondary and tertiary amines. Then we can say that the secondary amines are called as the strongest. The secondary amines are called as the strongest among these ammonia, primary amine and tertiary amine. So it is a very much important clue we get from this table that secondary amines are strongest. Secondary amines are strongest. The secondary amines are the strongest, and after that we can say here, next we can say here, all amines are stronger. All amines are stronger than ammonia. All amines are stronger than that of the ammonia. Now we have to give justification that why this secondary amine is the strongest base, because our expected order of basicity is that this tertiary amine must be strongest base. But if we look towards this type of the experimental data, it is clear that as compared to tertiary, the strongest base is a secondary amine. So we have to give the justification why this is so. So in order to consider the strength of bases, some factors we have to take into consideration. So first important factor is that this basicity depends upon the availability of the electron pair, how easily it can available the electron pair for donation, as well as a second important factor is there, stabilization of the conjugate acid. The most important factor is a stabilization of conjugate acid. stabilization of the conjugate acid, and this is the most important factor as far as the strength of the bases is considered. Now this conjugate acid which is formed is not only stabilized by the plus I inductive effect, but the second most important effect, that is called as the solvation. So this stabilization of conjugate acid is important as far as the strength of basis is considered, and this stabilization can be done with the help of two different effects. One is called as the plus I inductive effect and second is called as the solvation. So we have to take into consideration these two important effects. First is the plus I effect and second is called as the solvation. Now if we consider this second effect, that is the solvation, for these three different amines, what we consider here, if we want to study this solvation, first of all we consider here the conjugate acid of the primary amine. So what is that conjugate acid for primary amine? It is the R single bond nitrogen, single bond hydrogen, again this is a single bond hydrogen, again the third proton is there H, a positive charge is there on this nitrogen. Now this is a conjugate acid of primary amine. This is a conjugate acid, conjugate acid of primary amine. This is a conjugate acid of the primary amine. Now what happens? How many solvent molecules are involved in this solvation? So first of all, this is a proton. So first water molecule is there, this is OH2. In this case also a water molecule is involved for solvation, and in this case also a third water molecule is involved, that is in order to carry out the solvation. This is the first case. Now if we look toward the second type of this amine, that is a secondary amine. So in this case also we have to study the solvation effects of phenomena. So these two protons is there, again this nitrogen carry the positive charge. So how many protons are available? Two protons. So again it show the solvation with that of the water molecule. This OH2 is there, again this is a second OH2. So this is a conjugate acid, this is the conjugate acid for secondary amine. This is a conjugate acid for secondary amine. And in the last case we have to consider here this conjugate acid for the tertiary amine. So what is the tertiary amine here? R single bond N, single bond R, single bond R is there, and one proton is available. Again this nitrogen has the positive charge. So as one proton is available, it forms a partial bond with that of the water molecule. So this is called as the conjugate acid. This is the conjugate acid for this tertiary amine. Conjugate acid for this tertiary amine. So we can say here this solvation is important as far as the stability of the conjugate acid is considered. So what happens here, if we consider the solvation is there. So as we go from this primary amine to the tertiary amine, what happens here? So these are the two different effects is there from left to right. If you go from primary to the secondary, and in a second opposite case if we go from this tertiary to the primary amine. So what happens here, as you go from primary to secondary to the tertiary amines, so what happens here, inductive effect increases. Means we can say here plus I effect increases basicity. Plus I effect increases basicity. Why this is so? Because as we go from primary amine to the secondary to the tertiary, more and more alkyl groups are added. In this case one alkyl group is there, in this case two alkyl groups is there, and in this case three alkyl groups is there. But if we consider the second parameter, that is called as a solvation, so what happens in a solvation? If we go from tertiary to secondary to the primary amine, what happens? Solution effect decreases basicity. In this case, solvation effect decreases basicity. Solution effect decreases basicity. Why this is so? Because the solution is important as far as the stability of the conjugate acid is to be considered. So by taking into consideration these two different factors, that is the plus inductive effect as well as the solvation, so we can say that these two effects get obeyed by the secondary amine, and that's why the secondary amines are called as the strongest bases among all the amines. These two effects get balanced at this secondary amine, and that's why the secondary amine is called as the strongest base as compared to other remaining amines as well as the ammonia. So this is the most important anomalous behavior of this particular secondary ammonia, that even though more alkyl groups is there in this tertiary amine, means it has the three alkyl groups which shows the plus inductive effect. In this case only two alkyl groups is there which show the plus inductive effect. But what happens? The solvation is very important as far as the stability of this conjugate acid is concerned. So in this case two water molecules are involved for the solvation, while in this case only one solvent molecule is involved for solvation. So with the consideration of these two different effects, we can say that the secondary amine is called as the strongest base as compared to primary as well as the tertiary amines. So we studied the two important examples for this basicity. The first simple example we considered in the last lecture, that is this methylamine is the strongest base than that of the ammonia. And in this current lecture we studied the different strength of bases in the terms of ammonia as the different amines. So this is the case for strength of bases. So in this current lecture we studied the important point, that is the strength of bases, how the strength of bases get vary in the case of the ammonia derivatives, how these effects get affected by the presence of the different type of the alkyl groups. So what is the expected order of basicity and what is the actual order of the basicity. So with this I stop here in this current lecture. The remaining point we will take in a next lecture. So thank you so much.